850 degrees Celsius. And the spontaneous ignition is about 600 degrees Celsius. So why we use timber? There's a benefit of use timber. Store vast amount of carbon, yes, help to meet climate targets. Simpler and faster to construct through the prefabrication process because it's safer and quieter building sites. Fire resistant because the emission of fire requires 600 degrees Celsius. Provide better cost certainty, better insulation properties, and also healthier environment. Because timber is a biophilic material. Okay, some data from the census study from Department of Statistics Malaysia. This is the latest one because the census study for this year is being carried out, and we get the data maybe next year. So 2016, you can see here, timber product in terms of value is 7.31 billion. For timber framing system is 0.08 billion. So total value of timber usage in 2016 is about 7.39 billion. Compared to the total value of construction material, 97.13 billion, is about 7.61%. So, some facts on figure for timber building over the world is about more than 60 completed mass timber building all over the world. And the highest timber building in the world, triple in just 10 years, and about 70% of a timber building is located in Europe. Okay, I share to you some of the highest building in the world, timber building in the world. Starnek, Bermuda, Norway. Okay, 18-story, mixed use of building, 85.4 meters high, and currently the world's second tallest building. And this is the new world tallest timber building, Ascent, Milwaukee, USA. It's about 25-story high-rise building of 87 meter high, and a system of glulam, beam and column support cross-limited timber floors. So the number of mass timber building is expected to double every 2 years through 2034, which is point construction industry is about storing more carbon than it emits. And then in the future, we will see more tall buildings, modular construction, pre-designed building, hybrid technologies, multiple building projects, timber district, and so affordable housing projects. And according to the World Green Building Council, every building on the planet must be net zero carbon by 2050 to keep global warming below 2 degrees Celsius. And the challenge is the opportunity for timber to reduce the embodied carbon. And using timber in construction, if conventional building releases 2,000 metric tons of carbon, an equivalent timber building will store the same amount. And in fact, for every dry ton of timber produce 1.8 tons of CO2 is taken from the atmosphere. And does timber store carbon? Yes. Timber is a carbon negative building materials. And structural timber is made of approximately 50% of carbon by dry weight. And it also widely accepted globally because France required all new public buildings to use at least 50% of timber. Amsterdam required all houses to have at least 20% of timber. Australia 2032 Olympics is targeting at least 40% of timber, and this may possibly move to 100%. And what about Malaysia? Okay, MTIB together with UiTM has conducted a nationwide study to see the feedback and the perception of using timber in construction. We have some objective to identifying factors that support or influence timber usage, and also the challenges and issues on timber usage. Comparing costs of timber usage for other material, UBL policy review and strategies and recommendations. And our target group is a public, manufacturer, and also a developer. And I will share some of the data that we get from the study. The opinion on timber as a green and environmentally friendly material in construction. So about 89.4% agree that timber acts as a green and environmentally friendly material for construction. In terms of preferring material used in construction, timber is number 2, 57.5%, because the reason of aesthetic value, environment, and also comfort. And awareness of timber usage in the construction industry, almost half, 54% of the respondents were positive about using timber to build their resident or business premise. And also, when asked, about 62% said that the quality of timber used in the construction industry are in good quality. And the respondents were divided whether agree or not if the government to impose a policy that at least 10% of a building has to be made of timber. And the preference of timber usage in construction industry, I want to highlight this: environmental friendly material. Mostly 36% agree and 30% strongly agree to use timber. The reason for use timber for environmentally friendly material. And in terms of awareness of usage of timber in the construction industry, the level of support for the use of green and environmentally friendly material for construction, almost 90% survey were aware that timber is necessary for the green and environmentally friendly building construction. And the public highly supported the use of green and environmentally friendly material for construction. And this is, we try to get 3 factors, using cost, durability, and fire resistance to examine whether the impact of public preference for using timber in building residence. And based on the model, indicates that the preference of timber increase if the cost decrease and fire resistance increase. So some suggestions to enhance timber usage: of course, the maintenance of forests, law and policy enforcement, alternative materials, and increased awareness. And as a conclusion, most of the public was aware that timber is green and environmentally friendly, and familiar with 2 species, namely Chengal and Meranti. And the public also has a good knowledge about plywood, fiberboard, blue lamp, LVL, and the preference of timber increase if the cost decrease and the fire resistance increase. And the common issues raised by the public is to be highly considered by the government of Malaysia, and to enhance the timber usage, issues of forest maintenance, law and policy enforcement, using alternative materials, and increasing awareness. Finding from manufacturer. Okay, factors that influence the choice of timber species production for non-structural product. Price, availability, and durability are the most influence factor for non-structural product. And for structural product is price, quality, and durability. Timber buy from certified timber supplier. Mostly, 57% of the manufacturer not sure whether to buy the timber from certified timber supplier. And finding for contractor or developer, the type of timber product used in construction, the highest is solid timber, 25%, plywood, 20%, glue lamp, LVL, CLT, and others. And for timber species used in construction, we have the highest, followed by Kempas, Cengal, Nyatu, Meranti, and also Keruing. These factors relate to non-structural and structural product used in construction. For structural product, most respondents agree that strength, quality, durability, and design as standard are the important factors using timber in construction. For non-structural product, most respondents agree that appearance, grain, color, texture is important factors. Okay, about the awareness of support and the incentive of timber usage, almost 58% of contractor and developer know about the support and incentive of timber usage in construction industry. And response towards the 10% policy, more than half, 54.7%, agreed that policy to be imposed by the Malaysian government for the structural building must be made of at least 10% timber. And type of support provided by the Malaysian government, 70% agree that provision of training skills by Malaysian government is number one support. For recommendation, yes, policies, you need to review existing policies to promote usage of timber. Rules and regulation, you need to improve effectiveness of the existing rules, standard and core practice, enforcement, and also the lobby group distributing knowledge and information. So it's a way forward. In terms of rules and regulation, this is the UBBL, Uniform Building Bylaw. This is important document that strictly considered a timber regarded as a combustible material. This is our main obstacle to use timber in construction. So a working group has been formed in 2018 to evaluate and propose an amendment to UBBL. Some of the focus of item 80, structure above foundation, 113, 133, 141, 210, and so on. And of course, in the X schedule, we want to put timber back to class 0 or class 1 item list. And recommendation has been made to make change to all amendments to the policies, and the UBBL recommend that discourage the usage of timber due to its combustible properties or fire regulation. And we want to convince Bomber on the combustible issue by changing certain clause in UBBL clause, such as fire rating or also charring rating, and CIDB to include timber in their scoring. Yes, MTIB work closely with CIDB. Some of the construction industry standard that we inviting MTIB to be there and focus to amend or revise the CIS 5 about the prefabricated prefab timber truss system, CIS 6 about the QA for the treatment for timber truss, CIS 18 IBS scoring system, and also CIS 24 about IBS system assessment and certification. And also, we work closely with Zakiah on the standard specification for building uses. Sorry, cannot see. Okay, in this section H, timber, joinery, and ironmongery works. We have the timber specification in construction in terms of timber quality, joint and assemblies, ETP, joinery and carpentry, flooring, roof truss system, and others. And some list of standards related to wood product and wood structure, MS on timber, MS on timber structure, MS on wood-based panels. For research and project carried out by MTIB related to ESG, as well as promoting timber uses in construction industry, some of the project that has been done with MTIB, one of them is engineered timber product development program as the structure in the construction sector. The objective is to development of strength class of 9 selected species of Malaysian tropical hardwood according to EN 384 and EN 338, and to generate data for the development of code of practice for structural use of timber on limit state design, to determine the mechanical properties of Malaysian tropical timber based on size specimen, bending, tensile, compression, shear, and modular of elasticity according to EN 408. Analyze the characteristic strength based on EN 384 and to establish strength class in accordance to EN 338. And another project, report on strength classification for tropical hardwoods by visual grading accordance to EN 1400081 and EN 384. The objective of project to get the evaluation from the University of Stuttgart on strength class for the 9 species developed from the previous project. And the main Target here is to get the strand class from Malaysian tropical timber to be incorporated with EN 1912 and also for the Malaysian timber industry to obtain CE marking. Another project, automated visual inspection, AVI, for the inspection for wood, color and defect toward the smart manufacturing for the timber industry in Malaysia. And the objective of project is to develop integration system for the classification of color, density, wood defect, equipped with smart manufacturing features to increase production and productivity. This is to reduce timber wastage, adoption of IR 4.0, increase productivity and also the quality to increase the production rate. Another project about hybrid green energy for local timber drying towards the sustainable industry located at Kampung Sepadan, Pahang. The objective is to conducting electrical and thermal energy audit activities in our drying factories, to develop a solar PV system to reduce dependence on electricity and develop a solar thermal system to reduce fuel costs to steam boilers. And yes, wood industry regulation compliance guideline formaldehyde release level from panel-based products 2023. This is related to ESG. Malaysian Timber MTIB has published a draft of technical regulation that outlined how manufacturers can measure the emission of formaldehyde from the industrial wood-based products such as fiberboard, particle board, and also plywood. The study of fire resistance of solid timber for timber structure. This is our project with UiTM also. The objective is to determine the charring rate value of solid tropical timber beams from various species, namely 8 species with different range of densities were exposed to different time of fire exposure, and to develop models of charring rate for tropical hardwood for different range of densities, obtain the initial stage parameters, which is reaction to fire, such as heat release rate, mass loss rate, and amount of smoke from each selected species using cone calorimeter method, and correlation to initial stage of parameter data between density and characteristic of timber against char rate, and to provide comprehensive data for the need of developing the Malaysian standard document, which is MS 544 Part 9 and Table 9 in the UBBL. And this is the 8 selected species. We have keranji, resak, keruing, white meranti, dark red meranti, kedondong, light red meranti, and jelutong. And the conclusion from this project, the denser timber tends to have a lower charring rate. And charring rate with heat release rate HRR from combustion characteristic is related to with fire resistant. Timber with smaller HRR generally have better fire resistance. And the heat release rate for timber is directly related to the rate of mass loss during combustion. And some of the project has been done by MTIB also. We have MITILAS, product certification, timber verification service, and also this is related to ESG. So, and timber usage policy. Okay, this is a government policy proposal so that the use of timber in the construction industry can be increased to a certain percentage, especially for the government project. And the recommendation from this draft of policy paper, the requirement to use minimum 20% value of non-structural wood, including ID woods. And the requirements of use minimum 10% value of structural wood in construction, and MTIB is given the responsibility of verifying the quality of wood products used in government projects. And as a conclusion, use of timber, especially engineered timber, in heavy construction in the developed country is not something new. And for Malaysia, it's the right time. Timber will be given place in our local industry. Thank you. Over to you, Prof. Zakiah.
Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon to all. Okay, today I will be sharing with you some of the research work on the usage of timber in construction industry, whether it is sponsored by MTIB or from other agency also, but some of the results I will not be able to share with you, but I will present it here because some of them belongs to the company, some of them are still not published yet, get the approval to publish. But just to give you some idea what we have been doing in order to promote the use of timber in construction industry. Okay, everybody has already talked about environment impact of construction material, in general. Because I'm civil engineer, so we teach design for concrete, steel, timber, and other composite material and new invention of product. We want to improve many things, especially when we want to make it green. Concrete also we want to make it green, but we are not painting green, but we want to make it green. Whether we modify the cement or whatever, we want to use recycled concrete, but it's no for me, Okay, how to make it bigger here rather than small, because I can't see. Now, we know that construction industry will give high impact on the environment, whether we use steel or we cut mountain or we widen the river to get sand, we cut the mountain to get the aggregate, we cut trees to make it into timber building, all have impact. So we cannot just say timber have negative impact on the environment, but when we make concrete, when we make produce steel, we also give impact to the environment. Timber we can grow back, but when we cut the hill will not grow. When we widen the river to get the sand, it will not come back. Only timber is more sustainable. I'm not being biased, but it's from the fact. Now, when we talk about construction, the construction industry represents 35 to 40% of the national energy consumption and produce 25% of solid waste. But when we talk about solid waste, you can even imagine if I have a demolished building, concrete building, where does it go? When I demolish steel building, where does it go? When I demolish timber, I can reuse the timber. Many houses, historical houses, made from Tengah Bala, we can reuse it, plain it. It's still nice. It's still strong. We can use it. So these are things that we want to talk about as G. And then the construction industry also use 50% of our primary resources. So we have to balance the usage of our primary resources so that we have enough supply in years to come. Okay, so we cannot just rely on concrete, we cannot rely on steel. Now the price of steel is so expensive. And we want to compare about the cost of timber. We say timber expensive, steel also expensive, it's getting more expensive. So don't talk about, when we engineer, when we design, we don't talk about comparing element to element. A piece of steel bar and a piece of timber. We don't compare that. We compare about the cost of the total project, because when we build concrete, the foundation cost is taking up much more than we build the timber building for the foundation. We talk about the overall cost. Of course, we need this because of our urbanization. So the thing that we think in the future, timber is the most sustainable construction material with proper management of our forest. Definitely, we have to have proper management of our forest. Even when we want to take sand, or we want to put sand, we want to produce take for cement and also other, we also have to look at the impact on the environment. For timber, renewable resources, definitely. We can construct it very fast, very clean, and wood industries have less pollutant, let's say biodegradable residues. Yeah, we can chip it off and can make it to other product, and then it's just a question of abundant resources. Yeah, I've been moving from one factory to factory and see they always complain about resources. Yeah, this is our issue now. Okay, again, environment, and when we talk about the impact of timber on the environment, yeah, for the energy cost to produce or to fabricate 1 kilogram material, when we compare timber, concrete, glass, and so on, timber use very little energy, and in fact, on the sequestration carbon dioxide, only timber that absorb carbon dioxide, the rest emit carbon dioxide. And when we talk about construction, we talk about strength to weight ratio. For steel, okay, the strength is 300, but the density is 7,850. When we take the ratio between the strength and the weight is 0.038. Concrete, the resistance is 30 megapascal, but the density 2,400, ratio 0.013. And then timber, let's say we take very low grade, 45 megapascal, but the density is only 800. The strength ratio is much higher compared to the rest. Yeah, so this shows also timber is actually good for construction. And why timber? Of course, less trades, less labor, that is also give you safer work site. And just now, Hilmi has already shown you all over the world, they have built the timber building much higher and higher, yeah? And they are getting higher and higher. In fact, people has already said that engineered wood will become the cheapest way to construct tall building in the future, because the price of steel, the price of concrete are getting higher and higher. Yeah, so in Malaysia, we also have to start thinking of that. Now, how this tall building is possible for us to use that timber for construction, because the timber are being engineered. We know that the timber in the forest now getting smaller because we didn't replant, and then we can't wait for 30 years, 40 years to cut it, so it's not that mature, we start to cut them. Yeah, so the diameter becomes smaller, so it shows that the density, the strength also will become smaller, coupled with the defect in the timber, and then for large diameter, a very rare species, very expensive and limited. So the way forward is definitely we have to engineer the timber so that the strength is maintained. Yeah, lower diameter, but the strength is higher. Okay, so we have to engineer that. So study, we don't have to reinvent the wheel. All over the world has already made research long time ago to produce this. I have more information how it started and all that, but today it's just to show what I'm working on. Yeah, so we don't have to reinvent the wheel. They have already done the test. Yeah, they have developed this engineered timber product, which is glue laminated timber. Yeah, and then structural wood, because every part of the tree we can use. Okay, we saw them to make glue lamp. The remainder size we can make it into chip. We can make it into strand and glue them together and make it into an element. Yeah, so it becomes structural composite lumber. But it's different. There are differences between non-structural and structural. So the manufacturing of this must follow certain rules and guidelines or standard in order for that material can sustain certain load. Yeah, have a specific strength so that engineer can use them for design. So it has to have a proper manufacturing standard for this product. Yeah, to make sure that it is reliable to carry certain load. Yeah, and then we can glue lamp is for the beam, for the column, but not wide enough to become load-bearing wall or load-bearing floor. Therefore, they come into another innovation, which is called CLT, cross-laminated timber, which is constructed in panel form. Depending on the machine, it can be as big as they want, to make it into floor and also load-bearing wall. Okay, and then the CLT is glued by glue lamp, and CLT are joined together by glue. Now, there are also situations where people don't want to use glue because of the case of formaldehyde, and then not suitable for the timber to be glued. So they innovated by using dowel to connect each sawn timber, or they use nail, okay, to form the element, because they have problem in gluing the timber. So that's also. Now, in order for engineer to use this engineered product for a building, so we have to design properly. Okay, so all this done in Europe for many, many years, but they concentrate on few species. Make sure we have more species, right? So they have very few species that they have been working for 30 years, 40 years in order for them to establish the strength data, and also to develop the standard, design standard, manufacturing standard. Okay, so they have that. And for glue lamp, they already have strength class for glue lamp. So if I want to design the element, the beam, for example, I want to use GL26, for example. I want to have 26 megapascal. All right, so they have this. Now it's just that we need to know which species that will, when I make into glue lamp, will fall in 26 megapascal. So the factory, when they produce the beam, they have to declare their own strength of the beam. If the beam they produce have characteristics similar in the table, then it's much easier for the engineer to use. But if they declare higher or lower that is not in the standard, then we have to use that according to the standard. For example, if they declare the strength is 27. Okay, they declare the beam that they produce is 27 megapascal. So the standard has only 26 and 28. Should I design based on 27? Or do I design based on 26 or 28? So I have to design a little bit lower, which is 26. In order for me to design, I not only need to know the bending strength, I need to know tensile, compression, shear, and all that. The factory only do bending, because the bending will determine the strength class. So the rest of that they don't have, So that's why we need to choose which one is related. That will be safe enough to design. Now, in strategic national timber industry strategic plan, by MTIB, they have already shown the cabaran semasa industri perkayuan. So under innovation, of course, I agree, kita kurang inovasi dalam produk kayu, especially produk kejutan kayu. Kurang kesedaran tentang aplikasi kayu dalam pembinaan based on the one that presented by Hilmi. And then we always copycat design, but I think that's the best way, because if not, we want to design a new engineered timber product, requires a lot of money. Okay, so for time being, to make it fast, we just copycat. It's allowable. They produce glue lamp. At first, it is they have IP on that. Now it's open, so everybody can produce glue lamp. Okay. Another one is for the engineer for tropical hardwood. Kurang engineering data for the engineer to design. So I add one more. Kurang data. Kurang engineering data. Okay. Now. So these are based on the information given in the IBS roadmap for timber 2013 to 2023 by MTIB. Jumlah keseluruhan bahan for kejutaan adalah 50.66 bilion, but only 5%, only 10% being used for pembinaan. But Pembinaan can be anything, not necessarily as load-bearing element. Yeah, so very little being used for buildings, construction. Okay, now when we look at the needs of increasing the use of timber in construction, because we want to pass the policy of 10% of the construction must use timber, because right now we have 90% IBS. Yeah, so from 90% IBS, at least 10% of that must use timber. Okay, must use timber. So we need to get ready of the product that can be used for construction. Okay, so we need to have that. Once this policy being passed, industry must ready with the product, must have enough supply. If not enough supply, then we have to get investor. We have to import. All right, so there are many things that we have to think about. Okay, but we want, because we know that in the future, timber will be the best construction material. Green, sustainable. Yeah, so we need to focus, we have to work hard in order to make it realistic in the future. Okay, now, in order for Malaysia and timber for construction, we need sustainable timber supply. Right now also bergaduh nak dapat timber supply. Okay, the one, when I visited, the one that can sustain their product and export, if they have their own land, they have their own timber supply, they have timber possession, yeah? Okay, they are given the plot for replanting and all that, then they can. But that is because they grow very fast, they do chipboard, they reduce MDF and all that. But for engineered timber product, they have to sacrifice certain things. The timber, they have to really take care of the timber, they have to do the pruning so that it goes straight, not much branches, no much dot, that will give you a quality timber to make into a good quality engineered timber product. So this also has to be strategically planned, yeah, by the timber industry, by the government, have to sit down and think about it in more detail, more concrete, not just saying, I have this strategy, but on the ground it's not happening. Okay, so there must be task force in looking into this more detail. Sorry, yeah. And then we need also to have good standard. We have to have promotion, we have to have education, we have to have training. Okay, now, are the engineer now ready to design timber building? Our standard available for the engineer to use? Now, not only design, but on the construction side, do have enough skilled people to join CLT with the glue line? What types of connection? Whether our connector supplier are ready in Malaysia to supply the connectors for the engineered timber product. So there must be workshop on the ground for the contractors and all that in order to make these things happen. Yeah, we cannot just let it go. There must be a strong task force on this. Of course, I agree with the policy. Sometimes when the policy starts, everything goes. Like we want to have IBS, concrete IBS last time. So at first also have got rejection, from many because they are prefer to do it on site. But once the policy is on, everybody starts to follow, right? Yeah, start to follow. We have to start. Maybe we cannot start 10%, too much, because we don't have enough supply, we don't have enough company. That will be long term. Short term, 2%, 3%, we go increase slowly as the market are ready. Yeah, but we need to start somewhere. Now, in order for us to have modern timber construction, we have to comply. We have to look back. I need to look back on this document, okay, because it was written quite some time. But these are the documents that we need to follow, yeah? CIDB building specification, JKR standard specification for building works, uniform building bylaw, we have to get we have to get approval from fire department. Now for engineered timber product, we need to have standard for manufacturing, and then we also need to have standard for design the engineered timber product. Now, we have a committee for timber structures. At the time, I'm chairman. I already retired. That's why my professor K, because I'm contract. I've been working not 24 years, almost 40 years. I'm old but look young, right? Okay. So we are strategically planned on the development of the standard. That's why whenever we want to develop standards for timber for Malaysia, our timber are different than the overseas timber. Okay, so the data, the design value in the standards varies. Okay, so that's why it costs a lot to prepare this. Like overseas also last time, they spend money, government spend money on preparing all these documents to support the industry to produce engineered timber product and do the construction on the engineered product. Without this, nobody can do that. Okay. Also, besides the code that we are working now, we also have to think about earthquake, about treatment, glue type, and many more. Anything that will make the engineered timber product reliable to be used. Okay, so it opened up a lot of research. Okay, so these are the design code, and these design code are based on permissible stress design. I'm sure some of you are not so technical, but this one is based on the material properties only. Now, they found out this design method is not economical, it's not 100% safe. That's why they changed the design method into limit state design that will incorporate the load and the resistance of the material together. Okay, so obviously they have changed the standard method of design into limit state design. So they are start to make the limit state standard not usable anymore, slowly. They are doing slowly. They are not abruptly, but still safe, but you are designing into a bigger size. All right, not economical size. Okay, because you put a lot of safety factor because the load against the material strength only, okay, for the permissible stress design. Okay, so now we are trying to move into limit state design. Okay, so Malaysian standard is based on permissible stress design. European, Canada, US, Australia have already changed into limit state design. Okay, so our standard also must move to the limit state design. What's the problem with the standard? Okay, our Malaysian standard, the information on the strength properties are based on our tropical hardwood. Now, if you want to adopt limit state design from Europe or from Australia AS standard for limit state design, but the strength values inside that standard are based on temperate hardwood and also softwood timber. So we can't use that. So we need to recalculate, okay, for our timber. So these are the related research work that I'm trying to work around, whether UiTM doing it or other university doing it, but hopefully it can be in the same idea and the same platform so that our target will reach. Yeah. So now we have laminated vinyl lumber. These are some of the products. We have done research on this together with UPM last time. Okay, we need to prepare the manufacturing guideline and also design data for LVL that we did in 2002-2003. And the test method is based on American standard. Now our design is based on European, so the test method need to go back to European. There are some changes, some a little bit different. Now, when we come out with the data, the strength values, we make it into strength grade because it's permissible strength design. But in order to limit state, then we have to maybe do again, or if we can convert, depending, European will not allow to convert, okay, to make it into characteristic strength, from grade strength to characteristic strength, and then give to the strength class. So it's a different method of defining or deriving the values, because when we use the design, the formula for both are different. Okay, so pening, saya pun pening sebenarnya, banyak. Okay, so for this LVL, we already come out with the design standard, we have the data, and then we also have books on manufacturing and all that, yeah, the outcome of that project. Then another one, yeah, because we want to start moving to limit state design, we start with solid timber first. So we have funding from MTIB to develop strength class for solid timber in structural science for the development of design standard for limit state in accordance with Euro Code 5 or EN 1995. In order to do this, we start with 9 species. You can see this is too technical, yeah. So these are based in MS 544 Part 2 and MS 544 Part 3. So they are based on permissible strength design, but Part 3 are based on conversion from small tier to large size, but the design data for MS 544 does not come out with glulam grade something. Still using solid timber, we design and predict what will be the outcome of the glulam when we produce it at the factory. So, okay, so that normally we try not to do that. And in Eurocode EN 1912, there are few species already available that give you the strength class. For example, Kapo, Compass is D60, and then Balau D50, and then we have also Kerwing, we have Merbau, yeah, but the one in EN 1912 were taken from the timber stated that is Asian countries. Okay, so it's representing many samples from Asian countries. So it does not represent Malaysia. Okay, it's Asian country, so they develop the value. Okay, so when under MS 544 Part 3, we adopt BS 5268 in 1998. Okay, Balau D70, Kerwing D50, Ladang Ranti is actually C22. C is considered as softwood, yeah, but then the strength, the positioning of that value is actually false, similar to C22. And then light red Meranti, yellow Meranti, and then Compass, dark red Meranti, but follow BS 5268. But when EN changed to limit state, they changed the method of deriving the values of the strength class. So Balau from D70 falls to D50. Okay, the rest are the same. Okay, at that time, because they don't want to retest, so they come out with certain formula, but they jeopardize the strength class of some of our timber. From D70 to D50 is quite a lot, yeah, for market value. But then that's what they can do at that time, yeah, because it's very expensive to retest. But their timber, for their timber, they have raw data from the beginning. They can do simulation and all that. They change from small clear specimen to large size. But for us, our raw data is not available anymore. If there is some yellowish paper already. So it's difficult. So we have to start again and see whether whatever they predicted there comply to our timber. So that's why we run the test. So these are the strength class in EN238 for hardwood. Yeah, the class is D18 to D80, and then they also have the strength class for softwood. Yeah, from C14 to C50. All right, they have changed the formula from 2010 to 2016. Okay, so these are the changes. Okay, I will not go into detail. And then also they have softwood tension test. They also have hardwood tension test. In our standard, we don't have tension test. Why is important to know the tension test? That applicable to the engineered timber product. Okay, we need to have the tension test because that's applicable to the development of the engineered timber product. So when we take up this project, we don't want to make mistake in deriving the strength class, in conducting the test. So I work together with Dr. Simon Iker and Dr. Jurab and Dr. Stefan. He's the chairman of EN Timber Structures Committee, who responsible in the development of the standard in Europe. Okay, so we will discuss with them how to cut the timber, how many sample, what and what and what, because when we read the standard, when we read the standard, sometimes we don't understand. And when we do the test, the rate that they put inside the standard, when we do ours, tak bergerak pun, because our timber is hard. So is it wrong if I do that or not? You know, when I submit to them, will they approve or not? So when they are present during my conduction of tests, so when they present it in the committee, hopefully they will not argue very much. Okay, kita kena ada kebijaksanaan juga, ya, kita nak pass through that. So in order to run the test, because I don't have, they have tensile test, yeah, for large size. So the size of specimen 19 times the width. So it can go to 2 meter, 3 meter. So kat lab kita selalunya pendek macam tu. And our timber is hard, the grip, it cannot pull nanti, dia akan slide, you know. So UiTM invest money 2.5 million. Sebaik saya pujuk, bos dapat lah juga 2.5 million untuk beli equipment. Yeah? So whoever wants to do the test on large size specimen boleh datang UiTM, tapi adalah bayaran sikit ya. Okay, so in order to do this, the timber must represent certain region of Malaysia to provide uncertainties. Yeah, so we dalam standard ada 5, kita can't afford to do all 5 region. Kita buat 4 tapi ada penalization, but still okay. And we have to make sure that the timber that we take from certified ladang ataupun tan, and then these are the number of sample, almost 20,000 sample. Pensan sudah PhD saja. Okay, we do many tests, and then we found out that dalam conversion formula tu dia ada satu formula mengatakan the depth factor tu hanya boleh digunakan if the density is below 700. Our timber density above 700. Can we use or not that modification factor when we want to derive the characteristic values? Okay, so kita tambah lagi specimen buat. Okay, kita found out bezanya sedikit saja. So for time being kita kata that formula we can use. Even in the design standard EN Euro Code 5 ada statement dekat situ, this modification factor is only for softwood only. Kita hardwood. So bila design pun kita nak kena tengok sama ada that modification factor. Bila kita nak develop our own standard, adopting Euro Code, so kita kena tengok that prosa tu nanti. Kalau tak sure, kita kena ada buat sedikit test just to verify that clause can be used for hardwood. Sebab European dia tak pakai hardwood selama ni. Memang dia tak pakai hardwood, dia memang pakai softwood. Lately saja dia ada buat kajian tentang hardwood, but to enhance the strength of the glue lamp for the top and bottom. They are not making full. Okay. So from this study, the strength class, geronggang pada dalam EN1 dan 12, kita dapat C16, karet mati maintain C22, mengkulang D40, kelat D40, keruing D50, resak D50, kapur D60, kempas D60 sama, kecuali balau kita dapat D55. Dia letak D50, kita dapat D55. So kita dalam standard kita akan letak D55. Okay, so di situ. Dan saya dah bentangkan dalam ISO committee our data. Alright. And then selain daripada glue lamp, dan kita ada solid timber dan kita juga ada buat glue lamp. So di sini yang pentingnya T-class. bila kita ada tension strength, kita boleh predict what is our glue lamp later on produce. Saya tak payah tunjuk sekarang lah ya. Dengan adanya tensile strength of the finger jointed and also the solid timber, we can predict bila dah buat nanti the glue lamp of what strength class. So itu nantilah ya. So these are the glue lamp, how you produce it. In the standard, these are the available. Dan kita pun ada buat glue lamp sebab kena cepat ya, nanti orang lapar. Kita ada buat kajian juga tentang glue lamp dan kita submit to also to Stuttgart untuk buat verification of the test, so that apa yang kita buat dekat lab sama, so that after that tak payah hantar ke tempat mereka. So what our testing method, our evaluation method sama dan betul. Okay, bila kita buat mengulang, kita dapat GL40. Remember GL40. Dalam Eurocode, the highest grade dalam standard is only GL32. Our timber from Mengkulang, Melanggangan, which is SG3, dapat GL40. 40. Dah terkeluar daripada table. Takkan kita nak design 32 sedangkan kita punya GL40 kan? Dan saya kena lengkapkan table tu. Dapat GL40 tapi saya kena, itu binding strength saja. Saya kena lengkapkan tensile, compression, shear dan sebagainya. So saya adalah buat test tu semua. Okay. And the tensile strength, dan kita dapat GL44 untuk crewing. Pun terkeluar daripada, padahal crewing SG5 bawah tu. But making into glue lamp become GL44. Dia punya tensile strength is 50. Kalau tengok table tensile dekat atas, the highest is only 26. Our timber is much stronger. So should we design based on their strength class, or we have to make our own strength class? We have to make our own strength class. Then our section, cross section will become smaller. Then it's more economical, more attractive to people. Kan? Begitulah. Sama light ram ranting is very low. GL22 dapat 19, which is almost high from yang lain. Spruce ke, Douglas fir ke kan. Dan betul yang saya tunjuk tadi, kalau strength class of lamination, the tensile strength of lamella T10, dia predict glue lamp dia akan dapat 20 megapascal. Kalau T24, dia akan dapat glue lamp of strength 32 megapascal. That's so benda macam tu lah. Alright, now kita dah buat tu. Another outcome of this, kita nakkan company di Malaysia boleh dapat CE mark if they produce their glue lamp. Ada orang luar nak beli glue lamp mereka, kita nak, MTIB nak pastikan that factory can dapat CE mark. In order for the factory to get CE mark, the species yang tak ada dalam EN 1912 tu kena register dalam European Technical Association Committee punya dokumen. So kita hantar about 9 ke sana. Jadi any company nak produce glue lamp, you boleh produce dalam tu, tapi untuk dapat CE mark, kita panggil CE mark punya auditor datang visit your factory and so on and so on. Okay, so then baru dapat. So ni ada prosesnya. Okay, kita dulu bid for 1,000 tak dapat sebab kita tak ada CE mark because international project. Tetapi alhamdulillah outcome of this project, Woolsmith telah dapat CE mark untuk crewing, GLTA untuk crewing dan juga GLTA is Australia. Alright, now ada new company yang akan buat CLT, which is 10 new company. Dah 5 minit ke? Oh. Okay, saya ada buat durability ya, yang ni projek dan saya buat CLT juga, buat dekat luar negara. Okay, sebab kita tak nak start inilah wall and then itu. Kita buat dekat this company, kita buat dua method, vacuum press dan juga hydraulic press to give the industry some flexibility in starting the business. Kalau pakai vacuum press 600,000 saja press tu. Kalau nak pakai hydraulic press will give you million. So to start small, dia boleh belilah, masih afford to buy the equipment. So kita kita dah buat, and then kita ada tak melaju lah, tak boleh. Kita dah ada come up with the guideline. Ya, kita dah keluarkan guideline, akan di-convert menjadi standard. Okay, fire issue juga. Okay, saya komiti untuk look back on the UBBL. Alright, alhamdulillah. Sorry lah Okay, kita buat reaction. Dah buktikan pun kali kita lagi better. Ada tunjuk result saja. UBBL baru dah keluar, tapi kita tak banyak buat perubahan lagi masa tu. Ya, schedule 9 pun masih belum sempat ubah. Tapi kita keluarkan mana-mana yang boleh membantu industri untuk guna kayu dalam construction. Okay, saya tunjuk satu last one. Okay, churning rate, Eurocode kat bawah tu ada beta 1, beta 2. Sebelum ni semua single saja. Now kita kena change beta 1, beta 2, which is one-sided untuk floor. Okay, two-sided untuk column beam kan, dia high exposure to round. Kalau floor tu is only one side, so to beta 1 one side, beta 2 to side tu. Kita dah buat a few places, kita learn juga how to analyze, how to get the value of the churning rate. Okay, so kita dah buat lah, kita tunjuk lah. Okay, kita buat juga LVL, kita buat solid timber. So saya nak tunjuk result dia saja, but I will not share you the slides sebab saya belum publish ya. Okay, pejam jangan digambar, pejam mata je. Okay, ini data kita daripada 9 spesies tu. Model kita sama dengan model yang dibuat untuk Eurocode, sama. So kalau Eurocode dia punya beta 2 is 0.5, yang dia orange tu, yang orange. Alamak. Dah baik. Okay. So kita memang bawah daripada 0.5. Nampak kita punya graf yang biru tu, dia make it platform 0.5 yang macam. Okay, tu saja. Satu lagi tambah juga, kurang kesedaran. Saya dah bagi talk 53 kali tau. Kalau tak dengar juga tak tahulah. Okay, itu saja. Terima kasih.